There could be hazardous gas.
You're
we don't
splitting hydrogen,
exactly.
so you can tube.
Maybe you can see that better. Okay.
Beginnings, they had more space. Now they are getting more and more packed,
full. Okay.
and it's not so easy to handle. Right.
So that's a simple way of taking away that electric risk. What's the difference between automating an electrolyzer and automating anything else? How do you reduce the explosion risk in hazardous areas? Very easily. This is what we're going to talk about today, where we're talking about automating electrolyzers. And with me, I've got an expert for that from Festo, who have been automating things for about 100 years. And I think he's been there for almost a quarter of that time. I'm very pleased to welcome a senior mechatronic engineer from that company, Alex Vargas.
Hi, Stephen.
Welcome. And I'm Stephen. I forgot to say that. Very welcome to Hyfindr Tech Talks.
Thank you.
Alex, what is the difference between automating an electrolyzer and automating anything else?
Well, the special case of an electrolyzer that you need to consider, it's basically a processing plant within a container nowadays.
Yes.
And what you do there is to split water, very basically using electrolyzers principle into hydrogen and oxygen.
Okay.
And hydrogen has special characteristics
Yes.
which need to be considered
Yes.
to some extent. And the equipment which I brought actually here,
Yes.
very clear ball valve with a quarter turn actuator, pneumatically driven.
Yes.
I brought also some pilot valve, solenoid pilot valve, and also valve terminal, which we are gonna talk later on in some minutes.
Okay, mechatronic engineer never travels alone. So thank you
Exactly.
for
Always
bringing
hardware with
these.
me.
Yeah. So this is a valve and some of the control elements. So it forms an essential part of the whole
Indeed,
automation
the
process.
core of the automation.
Okay.
Yes.
Okay. So again, difference between electrolyzers, as you said, we're making hydrogen here out of
Yes.
water, and anything else to consider?
Well, actually, you split into hydrogen and oxygen,
Yeah.
but what we want to get is the hydrogen.
Yes,
Usually
sorry.
nowadays,
You're
oxygen is not being used.
Yes.
But hydrogen has some special, as the smallest element in the universe, as you know.
Yes.
So related to leakages, for example, needs to be
Yes.
considered in the process valve itself.
Yes.
But it has also some characteristic due to safety
Yes.
need to be considered. But also electrolyzers, like we see here, they are also installed outdoors.
Okay.
Means low, high temperature need also to be
Okay.
considered.
So you brought this chart here,
Yeah.
and are both electrolyzers?
No, they aren't. Basically, what you see here is a very typical processing plant.
Yes.
They are chemical, petrochemical plant.
Yeah.
And on the other side, you see the electrolyzer. This is a very typical bigger plant, which is built only once in one spot in the world. A lot of years of engineering, and this customized specifically. It's being built once to produce several products over a certain period of time.
Yes.
The electrolyzer is actually also a processing plant with several functions, but nowadays it is being built in a container.
All right.
So that it can be really modularized and then built and reach, let's say, higher performances of megawatt, for example,
Yes.
by using several pieces, units of them.
Okay, so this is a once-off huge thing, sort of,
Yeah.
whereas this is almost like an engine that you would
Yeah.
build once. It's complex in
Yeah,
itself,
to some extent,
but you
yeah.
could just put several of them, and then you just have a bigger one. Yeah,
Exactly.
yeah.
And
Okay.
especially this is being built in a specific spot in the world.
Yes.
Whereas an electrolyzer is being built obviously at the manufacturer, but
Yeah.
then it's being sent out and installed everywhere almost.
Okay,
If you have
okay.
projects for hydrogen nowadays,
Yes,
they
yes.
are either on the desert or in the northern part, so low temperature, high temperature, for example, needs to be considered. And all these brings out the special case of the electrolyzers.
Okay.
you know.
So, Alex, what does the automation actually do then in the electrolyzer?
Well, yeah, the automation is, as I said, you have an input, which
Yes.
is water,
Yes.
and you split it into hydrogen and oxygen.
Yes.
This doesn't happen by coincidence,
Yeah,
obviously.
yeah.
You have different devices. Actually, you can see it here. So you have an electrolyzer, and you have the control of the fluid, either the water or the gases later
Yes,
on.
yes.
They can be either modular, means in the controlled valves, so process valves themselves,
Yes.
controlling on a proportional way or just on off. And this is, for example, what you have here.
Okay.
This is just a ball valve,
Okay.
where you have on-off functions.
Okay.
Means either flow is passing through or it is blocked.
Okay, so I know this is actually
quite heavy, actually. Yeah, and
but
this is a
I
smaller
wanted
one.
to have that here so that we can see that a little bit better. Okay, so here we have, you say it's a ball valve, so that
It
means
is.
this is actually the this is the pipe that
The
you
cane
can,
comes from the sealing element,
From the
which is a
ceiling?
ball itself.
Okay.
It's a
okay. So
hollow
like this
ball.
is open.
Well,
yeah?
this is
Can see
open.
you.
Yeah, you can see through.
Okay.
And it rotates 90 degrees and it's completely closed.
All right. So there's a ball inside
Yeah,
there.
you see here.
Yeah, exactly.
It's a floating ball
it's a
in this
floating ball.
case.
Okay, I think we can
And
see
this
that
usually
better.
is
this
the
this
pipe.
is this part here.
This is the pipe. Yeah, you can see
exactly.
the white parts are the sealing
The sealing.
elements.
Okay, all right.
And this is being piped usually, and this is where water or the gases or nitrogen, whatever, passes through.
Yes.
The device which opens and closes
Yeah.
this valve is exactly this one. It's
Is-
a quarter turn pneumatic actuator.
Okay.
Quarter turn because, as I said, 90 degrees,
Yeah.
then it opens and closes the valves.
Mm-hmm.
And the pneumatic
I'll just
because
move this across so we can see
yes,
that better.
the energy which drives this actuator is the compressed air, pneumatic. So it has internally two pistons
Inside there.
inside,
Yeah.
in a rack, a pinion in the middle.
Yeah.
So whenever air is coming into the actuator, it rotates,
Yes.
it moves the pistons, and then it rotates 90 degrees and opens and closes the valve.
Okay, so I think this is what we see also on so okay, this side has the same, does it have the same openings on both sides? I mean, we can see here that it's opening.
This is for the adjustment of the end position.
Ah, this, yeah,
This is a
okay.
mechanical end
mechanical
stop.
thing. Okay, so the
Um,
actual compressed air comes in
Comes
here,
in
on
here
this
actually
side.
through this device,
Okay,
where I
okay.
can show maybe here because it's
Okay, so you got
disassembled.
it. Yes, okay.
And this is the solenoid pilot valve, the one
Okay.
which is piloting this quarter turn actuator
Yeah.
to open or close the process valve.
Okay, all right.
So, and how does this work is basically that you have here compressed air pressurized the valve, and depending on how you commute the coil, you will open or close in different directions and commute or control actually the actuator.
Okay,
Yeah.
so this so
is-
essentially
These
this
are
is
the
air.
outputs.
Yeah,
This
exactly.
is
Yeah.
where it is getting into the actuator.
And
yeah.
then they will come in here. Okay. So, okay. Are there different approaches to automating these? I mean, automation is essentially, let me say, the remote controlling these
Right,
things. Yeah.
right.
And then you have a controller that decides, okay, now this open, that close. Yeah.
Yeah.
Are there different approaches to doing that?
Indeed, that's a very good question.
Yeah.
And there is one. So what you see here is a traditional way. For example, it is being installed in process plants.
Yes.
Very often in chemical industry, where with different pilot valves, I would say more robust coils and so on. But the basic principle is that this pilot valve is attached to the actuator. Why?
Okay.
Because you remember the picture we had with the bigger plants
Yes.
like this.
Yes.
There are far distance between the different actuators.
Yes.
And also, well, then it makes more sense to have the solenoid valve directly attached to the actuator.
Understood.
But now imagine when it comes to the electrolyzer.
Yes.
And I brought here a PNID just of the PSA, which is where the gas, the hydrogen, is being cleaned and dried out.
So, sorry to interrupt
Yeah,
you, but
no.
so this is the. I think we did a separate video on electrolyzers. Take a look if you want to, but this is essentially the last part of the
last part,
of the
PS
electrolyzer.
the PSA, the pressure swing absorption, is where
Absorption.
the gas is
Okay.
being dried and cleaned.
Exactly. Okay.
And this is the PNID, piping and instrumentation diagram. And what you can see here is the symbols. This is an example. Obviously, it changes from manufacturer to manufacturer.
Yes.
But you see the amount and the high density of these devices in a rather small, I would say, volume in the container.
Okay. So this would be basically
This
at
final
the
part
end
here, for
part
example.
here.
Yeah,
And so only this part would already have that many
exactly.
of these installed.
20, 30, depending on the
And this
performance
is
of
this
the
a typical
electrolyzer.
size in which they come? Wow, this is just so
I
heavy.
brought one to visualize it.
Yeah, that's
to
big.
make it
This is just so
to
heavy.
make it
This is
better.
how much this weighs.
However,
I would
but,
say at least
this is a
2,
DN
3,
DN50, 2
Yeah.
inches.
Okay.
But it can be obviously also smaller.
Yeah.
This would be
Okay.
probably potentially too big for an electrolyzer, but
Yeah.
Probably half inch, 1 inch. It
Okay.
really depends on the
Okay.
size and the dimension
But
of
this
the
certainly weighs,
electrolyzer. Also, if this
4
is
kilos
a
or
PEM
5.
alkaline and so on.
Yeah.
But this is a good device to showcase here.
Yes.
Also to
Yes.
show it to the
Okay.
yeah the details.
Yes.
Now, I was talking about, you remember,
Yes.
the high density of actuators within this PSA.
Yes.
And now you can imagine, if you have all this, I would say, with needs the cabling, the wiring,
Yes.
and also the tubing, so of the compressed air, to control this device.
Okay. Just taking it slow here.
Yeah.
So you have the actual medium, which
Yeah,
is
media, yeah.
connected here.
Yes.
Then this part is that cylinder which gets turned. Yeah.
Right.
through compressed air,
Yes.
which comes in here.
Yeah.
And this is the part that regulates how the compressed air
Exactly.
flows. Yeah, so this
Directs
is
the air itself. Yeah.
exactly. So, and then here, you say you have an electrical connection.
Yeah,
But-
because this is the
okay.
coil which is actually commuting this,
Okay.
I would say controlling the direction of the air itself.
Understood.
Yeah?
Understood.
That's what is called solenoid valve.
Yes.
Solenoid, actually a coil which
Coil,
is here,
yeah.
and then the valve. It's important also to differentiate whether we call it the pilot valve, the solenoid valve, and this is the process valve. Yeah? Because these are
Okay.
different names.
Yeah, because this is the valve that actually controls
really
the actual
handles the
process.
process.
So yeah,
Yeah.
and this is just the valve that controls the
Pilot.
pilot. Yeah,
Exactly.
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 That.
Yeah.
Okay, and this is an indicator of how it's standing.
This would be, yes, this would be a visualization, an indicator.
Yeah.
Or in this specific case, it also has inductive sensors here, because whenever this is turning 90 degrees, it commutes and can also be used as an additional safety feedback for the PLC, for example, which is controlling everything. Yet
PLC being
indeed
the
the valve has opened or closed.
Okay, so
Yeah, you see here the metal contacts.
yes.
And then whenever this is positioned in, I would say, contacting here the sensors, then it will generate a signal. And by this, the PLC will know exactly
Okay.
in which position is the actuator.
But it's not
90
it's-
degrees.
It's not, okay, so this turns, but it's not possible to manually turn this.
If you
one.
can handle here 120 Newton meters, which is the torque this actuator will generate, yes, you might be able. No,
So,
this is
okay.
just the indicator.
It's just an indicator.
You need
okay.
6 bar of pressurized air,
Yeah.
and then you will easily, obviously, commute this valve.
Okay, so that means, so we have the PNID of the actual process here.
Yes.
But we don't have what we don't see here is the actual supply of pressurized air to these things.
Yeah,
probably,
because here you see what is shown here with the lines and so on are the
Yeah.
pipes itself.
Yes,
Different
the pipes
pressure,
itself, exactly,
and
the process.
You see the piping and the instruments.
Yes,
Yeah?
exactly.
Whether this is the different valves or
Yeah, yeah.
pumps or tanks
Yes.
or here sensors.
Yes.
But you don't see obviously the cabling
Yes.
or the
the-
tubing.
Okay. Yeah, so we were talking about different approaches
Yes.
to doing this.
Okay, yeah, good point. Coming back to this is the standard approach which we still see in the market very often. So,
Okay.
but you can imagine now, let's move to a visualization of the electrolyzer in a 3D design here, rendering.
Yeah.
And you see here, you have, for example, water treatment, the water softening, you have the stacks, you have the AD and the PSA, and everything within a container. So you see the high density of all these devices, and our approach, or what you can say, is also there's an alternative. This is one solenoid valve attached per actuator. You can also use what we call the valve terminal. Yeah.
Okay.
Like for example, this valve terminal is every slide you see here.
Yes.
This can replace one of these pilot valves. So
Okay.
you remove, for example, this valve, then you install a device like this,
Yes.
and from here you go with the tubing and directly to the actuator. So the coil, what you see here, is exactly over here. The valve body itself is this valve body, and then the output is coming from here. What does that mean? If you have, for example, the control cabinet in an electrolyzer like this, and you're using this kind of valve terminal,
Yes.
you are removing all these single pilot valves from the field, from the, let's say, processing part, and by this, in the area where there's, I would say, potentially also the exposure to hydrogen gas,
Yes, 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 yeah.
you're removing them and centralizing them, everything into this control cabinet.
Yes.
And by this, very often you can, since you are taking away the electrical actuator here, the coil, out of this field where there might be some hydrogen leakages and so on, and you can reduce at least the hazardous location rating of the coil, yeah, explosion-proof coils, or even get it out completely. It really depends on the setups of some OEMs and manufacturers of
Yeah.
electrolyzers, where this is actually a non-hazardous location anymore. So you reduce first the risk, you reduce also the cost, because a non-explosion-proof product is obviously less expensive
Yes. Yes.
than an
Yeah.
explosion-proof rated. And we see several advantages if you are using a valve terminal like this. Everything is centralized.
Yeah.
You can imagine it's less wiring.
Yes.
If you're using here a field bus system, for example, to the PLC, then obviously you need less remote I/O cards.
Yes,
Use
yes,
the PLC with the
Okay.
remote I/Os, and also for the service.
The PLC meaning That's a control device,
Yes,
basically.
the programmable logical control, PLC.
That's exactly.
And the remote I/O stands for input-output modules, and this is what you have here. Everything of this, every single one will be an output to activate a coil, for example. And by this, you are taking them all away, collecting them into this device. This is actually a very small device with only 4 valves. Indeed, actually 2 blind spots in order to be able to extend it later on, for example. But this can have, for example, different versions up to 24 of them.
Right. Okay. So let me say in simple words, you're taking away the electrical component, which I mean, okay. First of all, I need to say this is an electrolyzer, and I'm very pleased, Alex, that you brought this one, because this is by Neumann Esser, and we did a video with Max here as well, which I really recommend to watch, because if you want to understand how this thing works in detail, that's exactly where it's here. Now, today we are looking at the automation element of it, and so what I understood from you now is that you have this zone, which is the process zone, where there could be hazardous gas.
You're splitting hydrogen, so you cannot avoid that.
So there will be hydrogen. Actually, there hopefully will be hydrogen.
Hopefully inside the pipe, not outside.
But when you have a valve like this where there could be a leakage, obviously this is an area of hazard. And if you have electrical components in this area of hazard, that they become more expensive, because you need to make them safe against those hazards. And what you're saying is you can do that all here. And then there will be just an air pressure pipe going to here.
Exactly.
So that means there will be no need for an electrical component here again.
No need for this pilot.
For this pipe, exactly. So you can basically take that off and just fit the pipe in, which then on the other end gets connected to one of these.
In this case, actually, this would be 2 tubings going to the actuator if this is a double acting.
Okay, so that's essentially these two.
Exactly. These two. This is what you see here. Obviously, this doesn't have any thread and so on, because this is a valve specially made in order to flange it directly to the actuator. That's how it seals.
Okay.
But in these cases, as you see here, this is usually assembled. What you see here, this is the sealing and the tubing, because this is assembled to the wall of the control cabinet. This metal box, where it is, this can be assembled directly on the wall, so you don't need tubing internally, also within the cabinet. And you have the outside box, everything is protected, also mechanically, if this is even additional the case, and you only have the tubings from the bottom.
And this part is the part that would then go into the process area.
They will be looking or standing out here to the bottom of the control cabinet. And from there, you just go with the tubing to the different devices or actuators you have in the field.
Okay. So that means then, so am I not replacing, let me say, well, I mean, I see the advantage of, let's say, taking away then this cable. But am I not replacing one cable with 2 pipes? Isn't that even more that I need to do?
No. Well, anyhow, you definitely need a pneumatic actuator needs at least 1 tubing.
Okay, so there will be tubing here anyway.
Tubing, you have to have it anyhow. Otherwise, the actuator doesn't work. But since in many cases, in order to make sure that this is, let's say, addressing the safety topics, they will mostly be single acting actuators, means you open with the air. As soon as the air is not there, the spring internally in the actuator will close it. So you don't need 2 tubings, you will need only 1. In this case, we have 2 outputs, but if you would be using single acting actuator, you will have only 1 tubing. So either way, in this case, either you have 1 tubing from here to the actuator, or you have it anyhow to supply the valve, what you have here.
Plus the cable then.
Exactly.
Okay, so actually essentially we'll have just 1 tube and then we'll just take away the cable. Okay, so that's a simple way of taking away that electric risk out of this hazardous area in that sense. Okay.
Not only, again, so obviously the electric risk, this is one advantage, as I said, so reducing the I/O cards, having it more centralized in a cabinet for the operator. Keep in mind, you remember I said the electrolyzers being exported worldwide, installed somewhere where you cannot say, for example, or potentially you need to train your team to address also the different, the maintenance and operators. And we believe that it's much better and easier to have it centralized than you have here the device, and then you can check whether everything is working properly. Instead of going into this part of the electrolyzer where nowadays they are actually quite packed.
Okay.
It doesn't have, I would say, on the beginnings they had more space. Now they are getting more and more packed,
full. Okay.
and it's not so easy to handle.
To even to get to that.
Yeah,
level.
exactly.
Okay.
Exactly.
But then, okay, now we are, let me say, one critical point, which I think also determines the cost. So maintenance, you mentioned, So it's easier if you have it there. But like, do you have any data on, let's say, the durability of this? Does it make it more, let me say, more easier maintenance? You say because it's easier to reach. I don't know. I am not so experienced in laying out piping for gas, but I think that, I mean, there's a lot of experience in putting out electric cables. So what would you say to that? Like, what's the situation in terms of maintenance?
Maybe I heard tubing for gas.
Yes.
So what you have is here compressed air.
It's compressed air. Okay,
compressed
maybe,
air.
yes, yeah.
Indeed, I fully agree.
Yeah.
Here, where you have the hydrogen,
Yes.
this is something which needs to be addressed because
Yes.
hydrogen is such a small molecule that it actually needs to be considered in the connections.
Well, when I
and
meant
so on.
gas, I
Right.
meant air.
Yeah.
I'm sorry.
Air.
Air.
Well, you can see it here. This is what we have. If you are using this kind of, which is the standard in the industry, pushing fittings, you just, I would say, squeeze in or put in the tube.
The tube,
is flexible tubing, very
okay.
important.
All right.
So either it is flexible tubing or rigid tubing.
Okay.
And then we are talking about completely different, I would say, levels of costs then also. If you are rigid tubing, the bending, the maintenance, it's not so easy.
Extra.
We go here with a flexible tubing.
Okay.
And by this really the installation, so pushing in or pushing it out with these kind of fittings, which is standard in the industry, is rather easy. Really.
All right. Okay.
And every operator, I would say, from every kind of industry, this is standard in automotive, in food, in mining, in chemical industry, everywhere.
The inside of this. Okay, so this is, okay, basically you pop it in there, basically, and then check
Do
it.
you see, maybe if you really look into the holes, you will see that there are kind of like a device which really holds on in the opposite direction,
hold this there.
the tube.
Maybe you can see that better. Okay.
And
so
in order
there
to
you go.
release it, you have to push it on the side, and then you pull it very easily, the tubing out.
Okay, all right, okay. So that means you see advantages in terms of the maintenance and cost.
Definitely, and again, as you see here, these are the two different principles. We can go this way, we can go this way. We truly, by saying we, means like we at Festo at least, we truly believe that this is definitely an advantage by doing it that way, especially when the density and the performance of the electrolyzer are increasing and increasing. So more equipment, higher density, they will, and then the footprint, the size of this device, it's starting to get also to some extent also critical in the electrolyzers.
Okay, you say you at Festo. Okay, now one thing I can say is that you've been doing automation for 100 years. Have you really been doing that for? I mean, like
not me. I only 25 years.
Okay,
I have
so a
been
quarter
working at
of
Festo
that
25 years. No, but
Okay.
indeed we are very pleased to celebrate this year 100 years of Festo.
Okay,
Since our founding in 1925, and this is in doing automation all this time, and especially concentrated from the beginning our core DNA in pneumatics, but we have extended over the last year also into electric automation and controlled pneumatics, and so the product range is quite wide. What we have here is actually, this is a bigger range of what we call the process automation equipment for handling fluids, liquids, solids or gases, like we have here in hydrogen. But you see here, this device is a typical, so we call it the valve terminal, and this is something which is also being used standard-wise in many other industries. Became a standard, and we believe what is a standard in many other industries due to the examples we mentioned and the advantages. We truly believe that in hydrogen, with some adaptations in terms of temperature, in terms of functional safety, in terms of also the hazardous locations, it fits perfectly also to the hydrogen.
All right. Okay. So so that was nice having, let's say, this Festo view of automation, in the electrolyzers, and especially since you've been doing, there's still probably the software part of the automation, which we can talk about separately. But these are essentially core elements that actually make the automation happen. Alex, since you've been in this for quarter of a century, what do you see coming up in the next years in this area?
That's in terms of hydrogen.
In terms of automation of electrolyzers, basically.
Automation of electrolyzers. We believe there is something which is starting to gain some momentum in the process industries, which is the automation of modular plants.
Okay.
What does it mean? Then you actually split more or less, and we had that if you take a look at this container, this electrolyzer, you will see that there are different modules. You have the module of water, the water polishing. You have the water treatment, the chiller, and so on. If this gets bigger and bigger, I mean, I mentioned the space. It gets out of I would say, the standard container sizes.
Yes.
So we believe, or I personally believe, will go into the bigger hydrogen plant, so to speak, where you have areas where you have the water treatment, then you have the stack somewhere else. We have the.
But didn't we just come from differentiating it from the classic big plant in saying that electrolyzers typically are now coming more in the containerized form?
Yes, so and this is the standard nowadays.
Oh, this is the standard already.
I would say we are not an electrolyzer manufacturer, but these are the I would say the manufacturers. We see that everything is nowadays into the container, and I think it's a good way because it can be transported globally. Sure. It can be I would say ramp up, and also the scaling up. This is what is important. Also scaling up. It's much easier to have a standard kind of like a blueprint, and easily have like 5 containers side by side, and then you reach to 20, 40, whatever 100 megawatt plant. But in the future, we believe that this will be potentially be split into the different parts, and again go into the hydrogen plant.
Okay.
At least for bigger installations, and in this case, then the automation of modules means a modular automation will get more momentum and more acceptance.
Okay, so that means the water polishing in itself being
one function equipment,
one container,
or package unit, as we call it in MTP, this module type package approach. And the important is, now imagine if you have a plant like this, you might have a supplier for the PSA, a supplier for the water treatment, and so on. And the question is, how do they communicate to each other? You know, because you don't need to. I mean, you need to have a common language, a common approach. Make sure that this plug can work. And this is actually what this MTP module type package addresses, to have a kind of like a common language.
Okay.
So that the equipment, this package units, can be connected to each other and immediately start working. I would say plug and produce, as we call it, also in this MTP approach.
Right, okay. So
I personally believe that this is going in this direction. But not now. I think the containers are the container way. Is the way an electrolyzer will get more affordable, which I think it's also one of the key topics of hydrogen.
No, that's cool. I think, and also like what we just discussed about, you know, like taking away these electrical parts into a centralized. Could that also lead to make it more affordable?
Definitely. I mean, whatever reduces, especially more affordable if you take a look TCO, total cost of ownership. During the lifetime of an electrolyzer, obviously the service later on plays a key role.
Okay.
So very often we focus on capex, but take a look also over the during time operation time. Then we believe then it's important to take a look, deeper look into the automation concept, what we call the topology itself.
Okay. Cool. Okay. Well, thank you for that outlook. I will be watching this space to see what happens. And I mean, after we've talked about the electrolyzer container, maybe at some point we'll be talking about individual modules that make up that.
Potentially, I believe.
Alex, it's been an absolute pleasure. Thank you for bringing your automation things along.
You're welcome.
Thank you for seeing us here. And we hope you've enjoyed this session with Alex Vargas, all about automation. There are many more videos like the one about the electrolyzer we talked about. And as a matter of fact, if you're looking for components for the hydrogen industry on hyfindr.com, you will find so many of them. And you can get into contact with wonderful people like Alex who can help you with all of that. So thank you so much. Take a look around, subscribe to our channel, and keep building good stuff for the hydrogen economy. Thank you so much.
Thank you.